In this video, I'll be reviewing the mechanism that we will be using in order to oxidize isoborneol into camphor. In order to achieve this oxidation, we will use hypochlorous acid as the oxidizing agent. Hypochlorous acid can be formed from sodium hypochlorite, which can be found in common household bleach. I will also be reviewing the mechanism of forming hypochlorous acid from sodium hypochlorite. In order to form hypochlorous acid from sodium hypochlorite, we need to react the sodium hypochlorite with acetic acid. As you can see in this mechanism, the hypochlorite ion will attack the hydrogen of the hydroxide group of the acetic acid. This will result in the creation of the hypochlorous acid. In the second step, the sodium ion will ionically bond to the negatively charged oxygen, forming a salt. As a result, this reaction will give us the products of hypochlorous acid and a salt. Once we have these two products, we are ready to continue with our oxidation. This is the actual mechanism that we will be using to oxidize isoborneol into camphor. In the first step, the hydroxide group on the isoborneol attacks the chlorine of the hypochlorous acid. This results in the chlorine becoming attached to the hydroxide group and water being formed from the remainder of the hypochlorous acid. In the second step, the water that was formed in the first step takes the hydrogen off of the former hydroxide group of isoborneol and puts the electrons back on the oxygen, giving it a full octet. In the third step, water is again used to remove hydrogen, but this time we are removing it from the carbon that is attached to the oxygen on the isoborneol. The removal of this hydrogen results in an elimination reaction, which forms a double bond between the carbon and the oxygen, which also removes the chlorine from the isoborneol. As a result of this final step, we now have camphor as our final product. Thank you for watching this video, and good luck with your oxidations.